the Rhine-Westphalian Technical College in Aachen is at the forefront of this field. At first, the operation looks simple. The nodules are made smaller. And melted at a high temperature. A large problem is the low concentration of ores. More than 90% of the manganese nodules consist of sand and manganese. Both materials can be used, but are already in good supply on land. It is not necessary to carry out costly deep-sea mining for sand and manganese. In addition, iron and non-ferrous metals come out of the smelter together in metal clumps and need to be separated with other processes. Very little non-ferrous metal for a large output of energy. Amongst other things, it's due to this metal that deep-sea mining is still at the top of the agenda of the European Union. Nickel. Countless products rely on nickel to be produced. Stainless steel, for example, like the kind produced by this company and exported across the whole world. The steel industry remains to this day a backbone of the German economy. Due to the increasing urbanization, its importance will continue to grow into the future, as we also need steel for building work. But it is estimated that global nickel supplies will be exhausted in 40 years. And what then? Researchers are currently testing which substances can replace nickel, but the alternatives are not yet wholly convincing. Up until now, Germany has mostly imported nickel from Russia. The town Norilsk is Russia's center of nickel mining. Stalin built it purely for the mine workers. The extraction of ores has meanwhile completely destroyed the surrounding area. For strategic reasons, many countries are looking for an alternative to importing from Russia. For that reason, countless companies around the world are at the starting gates to begin with manganese nodule extraction over the coming years. They rely on the technical know-how from other projects. A Belgian company has already created artificial islands in many places around the world, using sand that has been pumped up from the seabed. If we believe the engineers, it doesn't make a big difference whether they extract sand or manganese nodules from the seabed. But is that true? With this so-called trencher, the Belgians lay cables and pipelines on the seabed. It practically presents a prototype for a manganese nodule collector, and in principle, it can be converted with just one tube. The market situation is clearly in the foreground for the Belgians too.
Well, we have 5 metals in the polymetallic nodules. It's copper, it's nickel, molybdenum, cobalt, and manganese. But we see this as a nickel project. Nickel is the most important metal in our polymetallic nodules.
The trencher is currently being deployed in depths of around 2,000 meters. It's been built especially for the high pressure underwater. Any sensitive electronic systems are hidden behind thick metal layers. The tank-like vehicle weighs 55 tons, and the collector is set to be even bigger. It's not difficult to imagine the havoc this would wreak on the seabed.
Ecological impact is always important, and we from the DEME group are doing our utmost to reduce our impact. And we have to also consider that we need those metals coming from somewhere. So terrestrial mining also has an impact, so we will do our best to prove that seabed mining impact is less than terrestrial mining.
A tube instead of a claw, a third larger, equipped with yet more robust chains. and the collector is complete, though it would be moving through waters twice as deep. All around the world, many companies are working on concepts for manganese nodule mining. Essentially, the principle is always the same. A tank-like vehicle is released from a ship onto the seabed. Technicians sit on board the ship who steer the machine. On the seabed, the collector sucks the nodules up. It takes the top 15 centimeters of the ground up with it and creates great swirls of sediment. Still in the water, the nodules are gathered in interim storage and finally are pumped on board. During the extraction, the sediment on the ground, which normally hardly moves at all, drifts through the water, only settles back down very slowly. The researchers on the Sonne are investigating what kind of effects that will have. A diving robot takes on the role of the collector underwater. It is lowered down firmly on the seabed using a remote control in order to imitate the damage caused by mining the nodules. The fine sediment can be dangerous for the animals and plants on the seabed.
There are in some parts reduced metals and sediments inside, which then consume oxygen in the lower water column close to the ground and then also release these metals. In the manganese nodules and sediments around them, there are some toxic metals such as copper, nickel, cobalt, rare earth metals, which have a toxic effect.
In order to see more precisely how the animals react to this disturbance, the researchers catch individual animals on the seabed using the diving robot and expose the released metals to a concentration that will be about realistic during mining. The sea cucumber tries to escape. It's determined, but unsuccessful. The marine biologist Pedro Martinez wants to understand which and how many animals live here in the manganese nodule fields. The so-called multicorer is meant to cut out samples from the sediment. Pedro Martinez is looking at the question of how the animals deal with being disturbed. As here in this very area, the animal world was disturbed by his colleagues 26 years ago. Has it recovered? There is much excitement as the sea researchers heave the multicorer back onto deck. Up until now, they haven't managed to take samples with it. And without that, the marine biologists cannot carry out any examinations. Did it work this time? The researchers have to accept another disappointment. No sediment has gathered in the pipes, only water. They have more luck using another method. Countless animals have landed in a trap on the seabed. The work begins immediately. Up to now, nobody has known which plants and animals live on the nodules and around them. If the animals don't appear anywhere else, it means that the mining of the nodules is their death sentence. So now every single creature will be examined on board and carefully categorized. All the samples are prepared to be taken away. Across the sea, they will later be delivered to laboratories all over Europe. A treasure chest of samples, comparable to the first German deep-sea expedition, and years of work for many biologists. Pedro Martinez can only conduct a precise analysis of the animals back on land, in his laboratory in Wilhelmshaven. It took weeks until the containers finally arrived. Just like before, unknown species are still sketched out today. For Martinez, it is certain that every single one of the tiny unknown animals could play an important role. Ecosystems are, after all, extremely complex.
Every kind is unique. Each plays a role in the ecosystem and also has a place in the food web. So if certain species disappear, even if they're small, that can then have a measurable influence.
The genetic analyses have not yet been concluded. The scientists will only be able to say in a few months' time what kinds of animals live solely in the nodule fields. Nonetheless, it is already clear.
There are very many species in the deep sea, and most remain unknown. We estimate that 99% of the species that live there have not yet been classified.
99%. With mining, we would wipe out life, without knowing how important these organisms could be for the entire ecosystem. An incalculable risk.